Alright, welcome back everybody. In this video we're going to look at the first couple of examples from the radius of convergence lesson. We'll talk about what a radius of convergence is and look at intervals of convergence and how we can find them. We start with the convergence theorem for power series. With this theorem there are three possibilities as far as convergence goes. There can be some positive number r where the series diverges for all values greater than r, where we're talking about the distance from the x value to the center of the series being r, but converges for all the values less than r. R here is our radius of convergence. Okay, and the other two possibilities, we could have the series converge at every x value, in which case the radius of convergence is infinite, and we could have the series converge only at the center, in which case the radius is 0. But the vast majority of series that we're going to look at will have some finite radius of convergence that we can determine by looking at the interval of convergence of the series. Okay? Up to this point, the only thing we know as far as determining whether a series converges or diverges is if it's a geometric series, we know how to find its radius of convergence by looking at when the absolute value of r is less than 1 in the geometric series. We'll learn some more methods, but we're going to start looking here with some geometric series. And whether you recognize this one immediately as a geometric series or not, if I rewrite this a little bit, it becomes more clear that this is a geometric series. This is the sum from 0 to infinity of the quantity x minus 3 over 7 raised to the n power. And so as we cycle through our values of n, we're just repeatedly multiplying by the quantity x minus 3 over 7 to get our next term. And so that is our r value for this geometric series. So in order to find, and I'm going to find the interval of convergence here and then go back to the radius of convergence. The interval of convergence, I'm going to take the absolute value of r, and that has to be less than 1 in order for this to converge, since it's geometric. I'll set up this inequality. Multiply all three parts by 7. And then add 3 to all the parts. And I get that the interval of convergence is going to be from -4 to 10. Now, as far as the radius of convergence goes, you know, we have the radius of a circle, which is half of the diameter. The radius of convergence is half of the length of the interval of convergence, and so it's just going to be a number. The distance from one end of the interval of convergence to the other is 14 units, and so the radius of convergence is going to be 7 units. And in fact, this particular infinite series is centered at x equals 3. And so the radius of convergence is the distance from the center to either of the endpoints of the interval of convergence. Alright, let's look at example 2. Find the interval of convergence of the series, and within this interval, the sum of the series as a function of x. So this is again a geometric series, which I can rewrite to make it more apparent that it's geometric. This is the quantity x minus 2, quantity squared, over 4, all raised to the n power. So to find my interval of convergence, I need that r value, what's being raised to the n power. I need this whole thing to be, the absolute value of that to be less than 1. And so this is going to be between -1 and 1. Well, because it's raised to the second power, what's in the middle here is always positive, and so it by necessity is always greater than -1 because it's always greater than or equal to 0. So I can lose that restriction. I multiply both sides of my inequality by 4 here. And then when I take the square root, I get back to a compound inequality. Because if what's being squared here is less than 4, that means that what's inside of the square is between -2 and 2. Now I add 2 to all 3 parts. And there's my interval of convergence. Now, we're asked to find the sum of this series as a function of x. If you think back to when we first talked about geometric series, the sum of the series was equal to a over 1 minus r, and so the sum here is going to be equal to a, which is the value of this when n is 0, that's 1, so a over 1 minus r, and the r value is what we use to find the interval of convergence. Man, I wish I could get a good functioning stylus. Alright, and we could simplify this. We'll multiply both numerator and denominator by 4, gets rid of the fraction in the denominator. We end up with 4 over 4 minus the quantity x minus 2 squared, which is equal to 4 over 4 minus the quantity x squared minus 4x plus 4. And so this ends up being equal to 4 over 4x minus x squared. Come on. Alright, and that is the sum of the series as a function of x. And so no matter what x value we would put into the original series, it would lead to a sum of 4 over 4x minus x squared. Alright, let's continue over on to the next page. And this is going to be our first test that we will use to determine convergence and divergence of series in general. We're now going to start expanding our knowledge beyond just the geometric series. And this is a great first place to start, the nth term test. A series, the sum from 1 to infinity of a sub n, diverges if the limit as n approaches infinity fails to exist or is different from 0. This is a very important note here. It is important to realize that we can never, and you guys know how often I say the word never, we can never conclude that a series converges from this test. The only two conclusions that we can draw are either that the series diverges or that the test is inconclusive. Okay? If the limit doesn't equal 0 of the argument of the series, then the series diverges. Otherwise, the test is inconclusive. So let's look at how we utilize this. We're going to take the limit as n goes to infinity of the argument of the series and figure out what that's equal to. If we find this limit as n approaches infinity of n over n plus 1, that's equal to 1. And so our conclusion is that this series diverges. Okay, let's do the same thing in part B. We'll take the limit as n goes to infinity and if you don't immediately know what that limit is, we can certainly investigate that limit using a table on our calculator. X squared minus 1 over 2 to the x. And we'll look at the limit of that as x goes to infinity. Come on. And pretty quick it becomes apparent to us that this is approaching 0. You know, when x is 100, it's 7.888 times 10 to the negative 27th. So this is approaching 0. What can we conclude from that? That the nth term test is inconclusive. We haven't shown that this series diverges. It still might. But we certainly haven't shown either that it converges yet. Alright, that's the end of this video. We'll come back in the next video and look at the remaining examples from this radius of convergence lesson. See you guys then. Have a great rest of your day.